A while back I was experimenting with this ultrasonic transducer thingy. It measures distance, and I was trying to use it to measure acceleration, except that it wouldn't work. And I started suspecting that maybe the pi wasn't fast enough, but I measured the pi, and the pi is plenty fast. And then I did another experiment about consistency of measurement, and the consistency of measurement was an issue, and I'm kind of wondering now why I'm getting that inconsistency of measurement. So let me show you what I've got going on and some of my ideas, and let's run some tests. So what I've got going on back here is the results of some software I wrote. I'll show you that in a little bit. But what it does is it tells me the average reading from one of the ports, channel 7, and it tells me the standard deviation, and it tells me the variance. And these last two numbers, there's some mathematical thing I got off the internet. Basically what they tell me is how far apart the readings are. Now what I'm doing is I'm just measuring this one resistor over here on the back side, and so the resistor should always give very consistent results. These numbers in theory should always be exactly the same number, and when they're not the same number there's probably some reason, and the reason is what I'm after today. Is it radio frequency interference that's leaking into these wires, or what else is happening? So let me show you some of the experiments I've run and some of the results I've gotten, and we'll go from there. One of the things I've done is I've tried shielding these wires in aluminum foil, and I've tried from one end to the other. It's just a small piece, and to see what happens to our values. And you see our values actually went up. So okay, well, if we ground it, perhaps if we ground the aluminum foil, okay, so our readings went back down, but they're still not as good as the first one. So yeah, RFI can be an issue, clearly. I mean, something happened here, and it looks like probably the clock or something is creating some interference, is picking it up in the wiring and creating different voltage readings, because after all, that's what we're looking at. We're looking at voltage readings here. So yeah, it's probably picking up some stray currents, and we'll take that off of there, and it goes back down again. So this is not really a consistent result. I'm not getting a really good result. But let me try. Let's try putting one of these suppressors on the wires, and we'll snap that around there and then see what the results are. Back here I've got the choke on it, so I've got the readings down to somewhere about 60. This middle column is the most important in most of these readings. When I move it, you can see I move it away. Readings go up significantly, and they become more random. So what this thing does is it suppresses RFI that's on these wires. So when I get it back near the pi, it seems to choke out a lot of it. But you notice it's not consistent either. I moved it back here, and the readings are above what they were before. So it's gone from 60 something to 80 something. Yeah, it's if it was RFI and this one thing was simplifying it or removing it, I should say, then that would take care of the problem. But as you can see, yeah, it changes it. It helps in some ways, in other ways it doesn't. So I don't think this is the final answer either. Let's try some other things. So with this, I've got a choke, and all of the main leads, the power, the data, and the clock leads are all wrapped around here. And again, we're not doing any better. We're getting relatively consistent results, but the data points are farther apart than they were before. So the smaller this number is, the closer the data points are, and that's what we're really going for. Okay, well, that's not it. So, I mean, it's starting to look like RFI is not the main issue. There's clearly RFI in here, but it may be 10 to 30% of the issues, but there's something else going on that's keeping these readings from being more accurate. Well, let's investigate a little bit more. Another experiment. Let's look and see what happens. I've noticed that when I move the wires, see this, how the readings change radically? And all I'm doing is moving this wire a little bit. Not a lot, just a little bit. And if I just, pardon my hand, move these wires around a little bit, you notice I got it to go from like 120 down to 58, 59. I haven't done anything else. Clearly that's not RFI, and what I'm beginning to suspect is the breadboard. I'm guessing that the breadboard is, the contacts in there are probably tinned, and they develop a layer of oxide. And as I recall, lead oxide, tin oxide, copper oxide can form a diode-like connection. See this? Just by wiggling these, I've gotten this number way down. Yeah, that when you move these around, it scrapes the oxide layers off of the contacts inside here. And one of the issues, very clearly one of the big issues, is something going on with the breadboard. And again, I'm thinking it may be an oxide layer on the contacts inside the breadboard. So for right now, that's my guess as to what's going on with the highly varied readings. That if I wanted to tighten up these readings a lot, I would have to do soldering or something that's a lot more permanent, maybe wire wrap, to make these connections between the device, the wires, and the analog measuring devices. Okay, well, let's go look at the software behind this, and we'll go from there. This is the software that I'm using to do the testing that you've seen. And normally the software is, it's 50-50 hardware software when you're working with a Pi. But in this case today it's pretty much we're testing the hardware on here. And the software, I'm not going to go over it in terrible detail because we've done this same stuff. This is a combination of a couple different things we've looked at in the past. And so I'll go over it quickly. This is written in Python 3. I'm going to test RFI shielding effectiveness, and as you've seen, a big part of the issue may not be RFI. Same comments as before. We're going to import the time in the SM bus, and that's for the I2C analog to digital converter. Grab the stuff from the bus. The device is at 48. This is my list of channels. These are the addresses for the channels and the bits we need to activate the channels. I'm going to only use channel 7 in the software. This is set up so I can use one channel or two channels or three channels, but I only need one channel to run this test. And here are some variables I need to store information. I'm gathering 5 data points, so when I do the standard deviation or the variance, that's based on 5 data points, and then I loop back and I do another 5 and another 5. So all of these lines you're seeing here are 5 data points, and then the next 5 data points, next 5 data points. This is just a storage, it's a matrix for storage. Usually I'm running 1,000 data points, and that's what you're seeing go down the screen. You could easily make that a for while or while true statement, so it runs forever. Here's where I do the 5 data points, and this is set up so that I can do more than one channel at a time. However, in today's software we're only doing one channel, so we're doing channel 7. Same old stuff. I'm going to do a bus write to set up the bus for reading, do a quick delay on sleep to let things settle, and then I'm going to do the bus read and grab the information, and again from channel 7. Then I'm going to do what we did before, and I'm going to convert the 16-bit data, 2 bytes, convert that into 12 bits, and store that. And then down here I'm going to do the conversion, or the calculation for the standard deviation, for the average, and for the variance, and that's all happens here, and prints it. And then I reset all those variables and I go back up to the top of the loop and I start over again. So that's all I'm doing, just running a continuous loop. That way, when I'm making changes, I can see real time what's happening, what effect I'm having. So whether it's wrapping it with aluminum foil or grounding the wires or whatever it is, putting a choke on it, I can see real time what is going on over here. And that is pretty much it. So you can see the results scrolling up on the screen. Okay, so I think my conclusion is, for right now, that the Raspberry Pi, the RFI, is maybe 10 to 30% of the issues with inconsistency of reading. And the other issues may be with the breadboard and connections that have oxide whatever and are acting actually as diodes, or their resistance is changing. So a little bit more experimentation, but again, right now that's my best guess. Okay, well, I hope you found it useful and interesting in your Raspberry Pi experiments.